Hello students, welcome to Study Doubt. This question is from Physics, chapter Ray Optics. In the question, it is given that a compound microscope consists of an objective lens of focal length 2 cm and eyepiece focal length is 6.25 cm, separated by a distance of 15 cm. How far from the objective should an object be placed in order to obtain the final image? At two positions are given in the question. First, least distance of distinct vision, it's 25 centimeter, and at infinity. This is the first part of the question. In the second part, we have to find the magnifying power of the microscope in each case. So let's understand this question with a diagram. This is our compound microscope, and in this compound microscope, here is the object present. Let's name it A, B. And from this object, two rays are coming out. So both the rays touches the objective. It's a convex lens, and convex lenses are converging in nature. So rays will converge, and after converging, they will meet on the eyepiece and form the image at this point. So here we name it as A dash, B dash. So we have to find what is the value of the object distance from the objective. So UO we have to find in both the cases. So let's note down the values. In the first part, it is given that focal length of the objective is 2 centimeter. It's positive. Focal length of eyepiece is 6.25 centimeter. It's also positive. Objective and eyepiece, both focal lengths are positive. The reason is this is a convex lens, and convex lenses are always converging in nature. And when it is converging in nature, so the rays will always form on the opposite side of the object. Like here, this is our object. So when the rays will meet, it will meet where? At this point. So this is the focus of the objective. Similarly, here you see these rays are somewhere meeting at this point when it is parallel. So we can say that this is our FE. So what you see, both are on the right side. But you might notice sometimes in the ray diagram, we are using FE here. So the concept is that when we have a convex lens or concave lens, we have two focuses. This is our first principal focus, and here is our second principal focus. So for the sign convention, we are taking the second principal focus, and its magnitude is same as the first principal focus. It means that with respect to magnitude, both are same, but with respect to sign convention, it's different. So as I told you, we always take the sign convention as positive, because when the object is on the left side, its image is formed on the right side. So that's what its sign convention is positive. Sometimes I notice a student get confused that the FE is on the left side, so we take it as negative. No, it's wrong. You always has to take with respect to right side. That's the positive. And in the question, the length of the objective and eyepiece is given as 15 centimeter. So we note it down. This length is 15 centimeter. So we have to first find the value of UO. So for that, we are going to use the lens formula. So what the logic we are going to apply it here? See, in the question, one more thing is mentioned. What is that? The image is formed at a distance of 25 centimeter. It means that here, this distance is given as 25 centimeter. So what is this actually? This is the image formed by the eyepiece. So this is the value of VE. And where it lies? It lies on the left side. So this value is negative. This is negative 25 centimeter. So what concept we are going to apply it here? Let's understand. As we know that this is our eyepiece, and we already know that the value of D is given, it's 25 centimeter. So basically it is the image distance with respect to eyepiece. Now focal length of the eyepiece is also mentioned, it's 6.25. So if you use the lens formula, In lens formula, we are using the relation between f, u and v. So v is already known 25 centimeter, f is also known 6.25. So based on that, we can find the object distance with respect to eyepiece. So let's assume that somewhere the object is present with respect to eyepiece. Let's take this is the object with respect to eyepiece. But this object with respect to eyepiece is actually the image with respect to objective. So here, suppose this length is given as 15 centimeter, and let's assume that this distance is x. So what is the value of the image formed due to the objective? It will be 15 minus x. So we can easily find the value of VO, image formed due to the objective. So this is now known. We already know that FO value, it's given 2 centimeter. So based on that, can we find the value of UO? Same logic, F, V and U. So U we have to find, V we already got, its value is 15 minus X and F is 2 centimeter. So we have to just relate this concept in numerical value. So let's solve it. So with respect to eyepiece, we can say that lens formula is 1 by Fe is equal to 1 by VE minus 1 by UE. 1 by 6.25 is equal to 1 by minus 25. Fe is equal to minus 25 minus 1 by UE. Further solving, 1 by UE is equal to minus 1 by 25 minus 1 by 6.25. It's equal to, LCM is 25, minus 1 minus 4, so minus 5 by 25 minus 1 by 5 centimeter. So from here we can say that UE is equal to minus 5 centimeter. Now, as we discussed previously, this x value will be how much? Just we found it. This is 5 centimeter. Minus and plus we are using for sign convention, but its magnitude is 5 centimeter. So what is the value of VO? VO will be 15 minus x, so it is equal to 10 centimeter. So same thing, we can write it here. VO is equal to total length minus UE, and we substitute the relation VO is equal to 15 centimeter minus 5 centimeter. It's equal to 10 centimeter. So the image formed with respect to objective is 10 centimeter. And where it is formed? It formed on the right side. As you see here, where it is formed on the right side. So what is the sign convention? It is positive. And now we use the, again, lens formula, substitute the FO is equal to plus 2 centimeter. Then we can find the answer. So for objective, 1 by FO is equal to 1 by VO minus 1 by UO. 1 by 2 plus 2 is equal to 1 by plus 10 minus 1 by UO. So 1 by UO is equal to 1 by 10 minus 1 by 2. Its value is 1 minus 5 by 10 equal to minus 4 by 10. So object distance with respect to objective is minus 10 by 4. It's equal to minus 2.5 centimeter. So we got the answer for the first part. And let's also find the magnification, means magnifying power. So for magnifying power, we can use the formula M is equal to MO into ME. Its formula is VO by UO bracket 1 plus D by FE. D is our 25 centimeter. So let's substitute the value. VO is 10 centimeter. We got it. And UO is 2.5 centimeter. We are only finding the magnitude of the magnification. So we just use the magnitude, sign is not required. 1 plus 25 by 6.25. So M is equal to 4 bracket 1 plus 4, it's equal to 20. So M is equal to 20. So the image is 20 times magnified. Similarly, we will solve the B part of the question where the image form at infinity. So here our VE will be infinite. So here we can say what changes we are going to do in the figure. Previously you noticed that image is formed at this point and this distance was 25 centimeter. Now this distance is now moved to at infinity, means these two rays are parallel. So parallel rays will meet at infinity. We don't know exact position, so we assume that it will meet at infinity. So our logic is same, nothing is changing. We again just change this d to infinity, means we can say that the value for the VE is at infinity. And already in the question focal length magnitude of the eyepiece is given. We have to use the lens formula and find the value of x. Here the x will change. This x is equal to 5 centimeter. It is for the first case. But in the second case, let's assume that in the second case this value is y. This is for the case B and this is for case A. And here our distance will be 15 minus y for the case B. This one was for case A. Logic is same, only its values are changing. So let's continue. So this we can consider this is at infinity. Now we have to find UE. This is our actually our y. So what is the value of it when we have FE given as 6.25 centimeter and it is positive. So let's again use the lens formula for eyepiece. So 1 by FE is equal to 1 by VE minus 1 by UE. So here 1 by 6.25 is equal to 1 by infinity minus 1 by UE. So we can say that UE is equal to minus 6.25 centimeter, because 1 by infinity is nothing but 0. So we can write it as. Now we got the value of UE and we have to find the value of VO. So VO is equal to 15 minus y, or UE it's equal to 15 minus 6.25. Only we consider the magnitude, sign convention not required. It's equal to 8.75. 1 by FO is equal to 1 by VO minus 1 by UO. So 1 by 2, that's the value of FO, divided by 1 by 8.75, we just found it here, minus 1 by UO. So 1 by UO is equal to, we can write 1 by 8.75 as 4 by 35 minus 1 by 2. So 1 by UO is equal to 70, we can take as LCM, 8 minus 35, it's equal to minus 27 by 70. And this is approximately minus 2.59 centimeter. So here UO is equal to minus 2.59 centimeter. So this is the answer for the B part. And similarly, let's find the magnifying power. So M is equal to MO into ME. So MO formula is VO by UO bracket D by FE. VO is 8.75 divided by UO is 2.59 bracket D is 25 and FE is 6.25. So when we solve, we get around 27 by 2. So m is equal to 27 by 2. It's equal to 13.5. So the image is 13.5 times magnified. If you have any doubt, you can mention in the comment box. Thank you so much.